This is my lab report about black hole. So the problem I introduced here is just find the mass of black hole based on the position that are given. Okay, like how do we find it? So, well, let me tell you the result first. The mass was 3.8 E231, and it was based on three assumptions that given data was accurate, and the gravity of black hole is the only force acting on the star, and Newton's gravitational force, remember there's a G m1 m2 over r square, is universal, so it just applies everywhere. So here is the initial condition. Star mass is 1.989 E230, time step is a day, and this is the position data they gave us. It's just a bunch of numbers, so I'm not gonna go through like each of them, but that they are just like numbers right there. So based on this, how do we solve like the problem? So how do we find the mass? So we gotta know the Newton's gravitational formula, which is F, the gravitational force equals G times m1 times m2 over r squared, right? That is both magnitude, okay? So m1, which is force of black hole, is derived from above equation, and this is just parallel part, this is just perpendicular part. Now we implement the data into Python. So the main point is actually here. What I'm trying to do is you have V initial and V final, and with this two you can find P initial and P final, which is momentum of initial momentum and final momentum. And with that data you can find dp dt, right? And with that dp dt, the quantity is equal to F nat, right? Now then you can find the R by subtracting x1 to the position of the black hole, which was negative 1 e to the 10, and y was negative 4 e to the 10. So you subtract this, so you add them actually, and you find it by using, as I said, mass is just this, Fg is net force, so you use that, and you will get a mass of black hole. As I said, I got 3.8 E231 as my answer, and again this is initial condition, which is black hole position and time step a day, star mass around 2 E230. In data file, as I show you, there's a bunch of numbers of position of stars, and the mass of black hole was right based on what I calculated. So let's run the Python to see how it looks like. I make it slower, so it goes slower so that you guys can see it clearly. And this black hole is right here, stationary, and you can see the black one was the F net, which was pointing toward the black hole, and parallel was just parallel to your momentum, and perpendicular part was just perpendicular to your momentum. So what does it mean? Okay, let's discuss this. Okay, you have dp dt, and you have dp dt parallel and dp dt perpendicular. So what does those tell you? Okay, you see, as you see at the arrow, addition of this two, the parallel one and the perpendicular one, will give you the final one, which is dp dt. And now you may ask, what's the difference between F net and dp dt? So according to Newton's second principle, which is momentum principle, the quantity is the same, dp dt equals F net. However, the concepts are different. Now quantitatively, F net equals dp dt, F net parallel equals dp dt parallel, and so on and so forth. But conceptually, Fnet is just force, it's just push and pull. I pull you, you got pulled by me, that's a force. But dp dt is actually changing momentum over time. So time is very small, but dp dt is actually more like momentum. It's a change, while Fnet is just like a push. So what if the question is the black hole stay the same, but the mass increase, but the motion of stars same thing. Okay, when they refer to motion, there's two things. Where motion, the position can be same, or they can refer to just like the shape of it. So it looks the same, it looks like it goes the same way, but in the position might be different. So if you get the data of the position, like new position data, because since the gravity is different, as the mass is different, you will see the position of the star will be different. And based on that, we apply the same thing and you will find massive black hole. Now, if motion refers to the position, so if the position is the same, which is impossible because the gravity increase, then it's kind of impossible. It's not kind of, but it is impossible because you are using the same position data to find the mass of black hole, which will give you the same mass.